All right, so today we're going to start nitrogen compounds. Okay, and the first thing we're going to talk about is amines or amines. Okay, now amines can basically be viewed as ammonia derivatives. Okay, and what happens in an amine or an amine is that, so for example, let's start with ammonia. I'm not showing the 3D shape, I'm just showing the Lewis structure. Right, this is ammonia. Now let's say that I replace one of the hydrogen atoms with an alkyl group, right? Now this compound over here is called methylamine, right? You have a methyl group bonded to an amine. So this is methylamine, all right? And this is what we call a primary. This is a primary amine. Okay, primary amines में क्या होता है? That one of the hydrogen atoms has been replaced by a methyl group. Okay, so if you look at another example of an amine, right, we have something like this. You have a CH3 and a CH3, let's say, and you have an H. Now this is dimethylamine. This is dimethylamine, and dimethylamine is an example of a secondary amine. Yeah. And now if you have, let's say, like 3 CH3, something like this, right? This is trimethylamine. Okay. Trimethylamine, and this is an example of a tertiary amine. All right. And we have also introduced, if you guys remember, we also introduced this when we were studying arenes, right? Which was, if you had a benzene ring bonded to an NH2, this is this particular amine is called phenylamine. So let's say that you had something like this, right? You had ammonia, okay, you had NH3, and you had, let's say you had ethylamine. Okay, you had ethylamine over here. So over here, ammonia, if we start with ammonia, what we have is this. Right? Now, we're trying to compare base strength. We're comparing the strength of these guys as bases. Right? These are proton acceptors, right? Or lone pair donors. Now over here, if for example, if you remember ammonia में क्या होता था? अगर H plus ions हों, right? So if you put ammonia, let's say in aqueous solution, right? It will make a dative bond with a hydrogen to form the ammonium ion, right? And a similar thing is going to happen here. Similar thing is happening here. You have CH3, CH2 bonded to an NH2. Okay, and the exact same thing is happening here. Okay, this guy is also basic, and it will form a dative bond with H plus to form this guy, CH3, CH2, NH3 plus. Right? Now, this is a stronger base than ammonia. This is a stronger base than ammonia because of the electron donating effect of the alkyl group. Because of the electron donating effect of the alkyl group, okay, what happens is that you have an increase in electron density on the nitrogen atom, making it more likely to donate its pair of electrons and form a dative bond with an H plus. Okay. So over here, if we compare, so over here you would say that ethylamine, okay, ethylamine is more basic than ammonia. Okay. Ethylamine is more basic than ammonia, and the reason why is because of due to the electron donating effect of the alkyl group. Alright, and the reason why is because the electron donating effect, also known as the positive inductive effect, if you guys remember, positive induction, okay. What it does is it results in an increase, okay. It results in an increased electron density on the nitrogen atom, okay, making it more likely to donate a lone pair of electrons and accept protons. It more reactive towards protons, okay, likely to accept a proton. This also explains that why when we talk about basicity, okay, that's again strength as bases, okay. Tertiary amines are the strongest bases, okay. They're stronger than secondary amines, okay, which are stronger than primary amines, which are generally stronger than ammonia. Okay. Again, the reason we see this trend is because of the electron donating effect of alkyl groups or alkyl groups, okay, results in an increase in electron density, or you can say negative charge on the nitrogen atom. Okay, making it more likely to donate its lone pair and accept protons. Now let's talk about the basicity of phenylamine versus ammonia. Okay. Now phenylamine versus ammonia की अगर आप basicity की बात करें, okay, ammonia is actually more basic. Ammonia is actually more basic than phenylamine. Okay. So we can write this down here as well. Okay. That in this list we have ammonia, and then phenylamine is the least basic. Okay. And the reason why phenylamine is less basic than ammonia is because if you think about phenylamine, this is what it looks like, right? You have a benzene ring bonded to an NH2, right? And if you look at sort of a 3D representation of the structure, this is what it would look like. Right? The exact same phenomenon is occurring in phenylamine that we saw in phenol. Okay. What that does is, what happens is you have resonance, you have the overlap of the lone pair, okay, or the lone pair जो p orbital में है nitrogen के, with the benzene ring. That makes the benzene ring much more reactive, just like phenols. Okay, इसकी भी benzene ring is highly reactive. Okay. However, what it does is it's more reactive as an towards electrophiles, because of the electron density in the ring increasing, but it's less reactive as a base. The reason why it's less reactive as a base is because, exactly, right? The overlap of electron density or delocalization of electrons into the ring means that nitrogen पे electron density कम हो गई. So it's less likely to attract protons, okay, and donate a lone pair of electrons. Over here we can say that phenylamine is less basic than ammonia, okay, because the delocalization of the lone pair of electrons, okay, delocalization of the lone pair of electrons results in a decrease in electron density on the nitrogen atom, okay, making it less reactive or making it less likely to accept a proton. Okay. And delocalization of the lone pair of electrons on the nitrogen atom, okay, or rather in the p orbital of the nitrogen atom. The p orbital of the nitrogen atom, okay, into the ring results in a decrease in electron density on the nitrogen atom, making it less likely to accept protons. So over here, this is its reactivity as a base. Okay, as a base meaning its reactivity when it comes to accepting protons on the nitrogen atom. Okay. On the other hand, if you talk about the reactivity of phenylamine, okay, okay, towards electrophiles. So phenylamine is much more reactive towards electrophiles than benzene. Okay. It's much more reactive than benzene towards electrophiles, and the reason why is again because of due to the delocalization of the lone pair of electrons on the nitrogen atom, okay, in the p orbital of the nitrogen atom, okay, into the ring. Okay. This results in a large increase in electron density in the ring. Okay. Okay, making it much more reactive towards electrophiles. And the evidence for this reactivity, okay, is if you look at the reaction of phenylamine with, bromine. Okay, so if you react phenylamine with aqueous bromine, you have the exact same thing happen here as you did with phenols. Right, you have NH2 here, and you have 3 bromine atoms substitute onto the benzene ring. Okay, and the observation is also the exact same. Right, so what you're forming here is 2,4,6. You're forming 2,4,6 tribromophenylamine and 3 HBr. is called 2,4,6 tribromo phenylamine. Okay, and this is also a white precipitate. This is also a white precipitate. So the observation over here is that you will decolorize aqueous bromine and a white precipitate will be seen. Okay. So it's the same. The test for phenols and phenylamine is identical. Decolorization of aqueous bromine and white precipitate being produced.